Hello everyone and welcome again to the Mathematecher channel. In today's video we will see how to find out the domain of definition and the derivative function of the following functions. First, the function f, of which the image fx equals 2 times x to the power of 3 plus 5 times x minus 1. Then the function g, of which the image gx equals 2 times x squared minus x plus 1 all over x squared plus 3 times x. After that, the function h, of which the image equals in terms of x, 1 over x squared minus x plus 3. And finally, the function k, of which the image kx equals x squared times sine x. So let's start by the function f. For its domain of definition, as the function f is a polynomial function, then every real value for its variable x has an image in the set of the real numbers. Therefore, the domain of definition of the function f, which is noted df, equals the set of the real numbers r, which also can be written as the open interval, negative infinity to positive infinity. As for its derivative f prime, we have f prime of x, that equals the derivative of 2 times x to the power of 3, plus 5 times x, minus 1, which equals 2 times 3x to the power of 3 minus 1, plus 5 times x to the power of 1 minus 1, minus 0. Hence, f prime of x equals 6 times x squared, plus 5. Now let's move on to the function g. We have gx equals 2 times x squared minus x plus 1 all over x squared plus 3 times x. So for its domain of definition that we note as dg, as our function g is a rational function, then it is defined as long as its denominator is different from 0. Hence x squared plus 3 times x must be different from 0, which mean that x is different from the numbers minus 3 and 0. Therefore, the domain of definition of the function g equals the set of the real numbers r, except the numbers minus 3 and 0, which also can be written as the union of the open intervals, negative infinity to minus 3, and minus 3 to 0, and 0 to positive infinity. As for its derivative, we have g prime of x, which equals the derivative of its numerator, which is 4 times x minus 1, all times its denominator, x squared plus 3 times x, minus the derivative of its denominator, which is 2 times x plus 3, all times its numerator, 2 times x squared minus x, plus 1, all over the square of its denominator, x squared plus 3 times x. Hence, after expanding and simplifying this fraction, we find that g prime of x equals 7 times x squared minus 2 times x minus 3 all over x squared plus 3 times x all square. Now let's move on to the function h. For the domain of definition of the function h, that we note dh, as the function h is a rational function of which the denominator is x squared minus x plus 3, then it's not defined if this polynomial denominator equals 0. However, if we calculate the discriminant delta of the polynomial x squared minus x plus 3, we find that it equals minus 11, which is a strictly negative value, which mean that this polynomial is strictly positive and never equals 0, whatever the real value of the variable x is. So the domain of definition of the function h, dh, equals the set of the real numbers r, which is the open interval negative infinity to positive infinity. As for its derivative, we have h prime of x equals minus 1 times the derivative of its denominator, which is x squared minus x plus 3 all over x squared minus x plus 3 all square, which equals minus 2 times x minus 1 all over x squared minus x plus 3 all square. Now let's end this exercise by finding the domain of definition and the derivative of the function k. We have kx that equals x squared times sine x. For its domain of definition dk, if we note as u, the function that associates to the variable x, the sine of x, and as v, the function that associates to the variable x, the square of x, Then as these two functions are defined and derivable on the set of the real numbers r, We deduce that the function k, which equals the product of these two functions, is also defined and derivable on the set of the real numbers R. Now, to calculate its derivative k prime of x, we will apply the rule of the derivative of the product on the two functions, u and v. Hence, k prime of x equals the derivative of the square of x times the sine of x plus the square of x times the derivative of the sine of x, which equals 2 times x times the sine of x plus the square of x times the cosine of x. As always, thank you for watching. Like and share the video if it was instructive for you. And subscribe to the channel and activate the notification bell for more of this content. And until the next video, have a great time.